In class example 1.43, we will apply multiple transformations to the graph and equation of an absolute value function. So here we're given f of x equals the absolute value of x minus 6 minus 4. Basically, an absolute value function that has been shifted 6 right and 4 down off of the origin. We're then given g of x, the transformed function defined by negative f of 3x minus 6 plus 3. In our first step, we're asked to construct a mapping rule for the transformations from f of x to g of x. And we want to be very, very aware of the fact that that 3 in front of the 3x has not been factored out. This is easy to miss, but is so important. As long as the b value is not written in factored form, the h value, or horizontal translation value, is not correct. By factoring that 3 out, we can write 3 times x minus 2 and know that we'll be shifting 2 units to the right. Now, our other transformations are a reflection in the x-axis, a horizontal stretch by a factor of 1/3, the shift 2 to the right, and then a translation of 3 up. Our mapping rule, therefore, will show, due to the vertical reflection, that y becomes negative y. Because of the horizontal stretch factor, that x has a coefficient of 1/3. And because we move 2 right, we will add 2 to the x value, and 3 up will add 3 to the y value. Let's transform each point on the graph that is indicated using our mapping rule. In the end, we see a reflected, stretched, and translated absolute value function. Now we'll find the equation for g of x in terms of x. This means taking the original equation and applying the transformations to them. Let's first apply all vertical transformations. It's important here that we apply the reflection prior to the translation of 3 units up. You'll notice, therefore, that we've bracketed the absolute value x minus 6 minus 4, multiplying it by a negative 1 before adding our 3. Now we will apply our horizontal transformations. This requires us to replace first the x with 3x and then the x with x minus 2. Or, in one step, we can simply replace x with the 3x minus 6 that was originally shown in the non-factored version. The result will be the same. As we simplify what is inside the absolute value brackets, we get 3x minus 12. As we distribute the negative sign both in front of the absolute value brackets and to the negative 4, we get a plus 4, which adds to the 3 to give us a 7. We can confirm using our graphing calculator that this form in terms of x will generate the same graph we've seen that we drew above.